Hi, I am Hafizur Rahman, a mixed fellow and PhD candidate at Graduate School of Science and Engineering at Saitama University. This is our first video from SIPLab, a signal and image processing laboratory. To discuss any topic, we will use MATLAB programming language in such a way so that this workout can be made in other programming languages like Python, C, C++, Java, and R. This video will discuss on images. At the beginning, images are acquired via image acquiring techniques. Although image acquiring is not discussed here, digital cameras use these techniques to capture images. Anyone having digital cameras or smartphones can capture digital images. These images are RGB or true color images. For simplicity, we will consider only gray images. In later videos, we would learn more on RGB and gray images. Now, first, we need to learn how to read images from graphics file, because programming language know the numbers, real or integer or complex number, and store those values in a variable. Now we have write here a is a variable that contains the image data, and here imRead is a MATLAB function, and every programming language or its packages has its own graphics file reading function. Here MATLAB use imRead, and in this string we are provide the path or directory and the image file name, which is this one. This is a PNG graphics file, and from this file, using this directory, it will enter this folder, and then the graphics file will be read by MATLAB using imRead function, and the RGB to gray will convert the true color image to gray images and will be stored in the variable A. And now we have seen this image is read already, and here A contain unsigned integer 8-bit data, that is the integer data in the range from 0 to 255, and most of the image processing operations use data in the range 0 to 1, and we have another MATLAB function like say into double. Here this value, unsigned integer type values contained in A, will be transformed into double type value, and whose range will be 0 up to 1. And why we use this? It is not mandatory actually, but it is helpful in many image processing applications or image processing methods. And now these values of A are contained in B, which are in the range 0 up to 1 and are of double type. Now, what is a gray image? A gray image can be considered as a matrix where the row number is the height of the image and the column number is the width of the image. And a gray level image is a function g of xy, which is presented as like g of x1 y1 x1 y2 dot dot dot, let we have n number of column in the matrix, and you can see this is a matrix representation yn, and then similarly t2 y1, second row first column, second row second column, and second row n column. And this is the mth row, that is last row, first column, last row, second column, and this is last row, last column. Here these are matrix element. When we consider it as a matrix, these are matrix element, but when we consider this matrix as a gray image, these are actually pixel. We know it as a pixel, that is a picture element. That is like atom. Atom is the unit to construct a material. Pixel element, pixel is an element to construct and picture or image, and the values are contained by them are known as pixel value. That is g of x, y contain a pixel value, and the smaller the value of g of xy is, the darker the pixel is, and the higher the value of the pixel is, the brighter the pixel is. Now the variable b represent it's a gray image whose pixel values are in the range 0 up to 1. As we said before, it is 0 up to 1. And today's video will discuss a point transformation or simply transformation for image enhancement, specifically contrast enhancement, named gamma transformation. And the gamma transformation is presented as like this. Here this is an pixel from input image, and this is the transformed corresponding pixel, and z is the gamma value. It is not 0, and k is a scalar. It also not equal to 0, and usually it is considered as 1. That is, k is usually considered as 1, and any other value can be considered. Now this transformation will be applied on all pixels of B. For the gray image B, all the pixels will get these transformations, and we need to know the size of B to transform all the pixels. That is, we don't know how many pixels we have, and that is the width and height of the gray image B, or if we consider B as a matrix, then the number of row and column are required. Now we have a MATLAB function to find out the number of row and column. As we mentioned before, that is, row represents the height of the image and column represents the width of the image, and size is the function that will tell us the number of rows and column of B. This is the B image or the B variable, and here 1 indicates row and 2 indicates column. That is, the row number will be stored in row and column number will be stored in column. Now we have two variables, column and row, and we will now use the gamma transformation like this. Before applying this transformation, we need a new variable like t equal to b. Here in MATLAB we can create a same variable like b using this command, and in C or Java we need to initialize a variable same type and same size like b. And now to implement the gamma transformation, we need this is the main stream code. This is a point transformation for as we will apply the gamma transformation on all the pixels of B, so we need two loops. I equal to 1 up to row and for j equal to 1 up to column. And we will store them in the corresponding pixel of D. Here we set the value of k is equal to 1 and the value of z is equal to 0.3, and integer value can be used. Here 1 into b of I j. This is the exponential function, actually the power operator used in MATLAB, and some other language can use this as power operator, and the gamma value we have used here is 0.3. And we can see the pixel at the position ij and its value contained in bij will be transformed using this equation, and this value will be transformed value will be contained in the corresponding pixel position in D. And this ends the codes, and after executing this we will get the transformed value in the variable D, and D is a matrix and that is the transformed matrix that contains the transformed value of D, and as D is a gray image, so we can consider D as a transformed gray image. and we get the variable d. And now we will see the original and the transformed image now. And to see it, we have a function named imshow for MATLAB, and specific language and its package has its own function to show an image from a variable or using the data in the variable. This is 1 by 2. The figure contains two images, that is use one row and two column for showing image. This is first image. The original image is in B. Again, number of row, number of column, the image number is 2. And this is transformed image. And imshow shows an image using the data contained in the variable B. Now we can see the transformed image. This is the original image and this is the transformed image. And if we use a value of gamma greater than 1, the transformed image creates darken effects, and for the values that are less than 1, we can see the transformed image will get a brighten effect. And the optimum value of gamma can be find out, and many researches have been conducted to find out optimum value of gamma. This is basic gamma transformations, and advanced gamma transformation can be found in literature. Hopefully we would discuss them later. And this completes the basic gamma transformations. See you again in the next videos. Bye bye.